Here's another standard enthalpy question where we use heats of formation found in Appendix 4. Again, the equation is the sum of the heats of formation multiplied by coefficients for all of the products minus the sum of the heats of formation multiplied by coefficients for all of the reactants. Any lone element or diatomic molecule will have a heat of formation of 0. That might save you some time when looking up in Appendix 4. So that means sodium, oxygen, here's sodium alone, and hydrogen here. All of those will have heats of formation of 0. So for question A, the heat of formation for sodium oxide is negative 416, and from that we're going to subtract 4 times 0 plus 1 times 0, which would just be 0. So your standard enthalpy change is negative 832. You could state that either as kilojoules or, if you prefer, kilojoules per mole. Question 2. For sodium hydroxide, it's negative 470. For hydrogen, it's 0. For sodium, it's 0. And then we have liquid water. Be careful, because there's two different heats of formation for water. One is for the liquid state and one is for the gaseous state. In this case, they're calling for the liquid state. And so crunching the numbers, that works out to be negative 368 kilojoules. And then for part C, we have sodium oxide again, negative 416. (110.5) for carbon monoxide. And carbon dioxide is negative 393.5. After crunching the numbers, this one works out to be negative 133 kilojoules. And then the last bit, they have a little chance for you to explain something. Why would a water or carbon dioxide fire extinguisher not be effective in putting out a sodium fire? A sodium fire. So if you look at the last two equations, we have sodium that reacts with water, and first of all, it gives you an enthalpy change that's exothermic. So putting water on a sodium fire actually intensifies the heat given off, not quenching it, and that the reason is because of this equation, it gives off, it produces sodium hydroxide and hydrogen gas, which hydrogen gas is itself flammable. So, and then the last equation, sodium fire reacting with carbon dioxide, also produces a exothermic reaction, and carbon monoxide is a dangerous gas in many ways. It is flammable, but it also can suffocate a person. So don't use water or carbon dioxide to put out a sodium fire.